Hello and welcome to this revision session for GCSE Separate Science Physics Paper 1 on the 2022 examination topics. So in today's revision session we're going to look at how we can answer examination questions on GCSE Physics Paper 1. So if we've been successful and we've learnt in today's lesson, we should be able to answer GCSE Physics examination style questions, assess our understanding of GCSE Physics, and then finally understand what topics we need to improve upon for GCSE Physics. So how can we be revising in this revision session? Well, when you're completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the section on the right hand side. In the left hand side section, write down your working out answers to the questions in the revision session, and when you do this, make sure you write out your answers in full sentences and show your full working out. Whilst in the right hand side, write down any piece of information which you find useful or any hints and tips on answering the questions from this revision session. And at the end of the revision session, write up these notes into a revision sheet for you to use independently. So we're going to have a look at a few questions now, and these are based on the topics which are going to come up on the 2022 GCSE Separate Science Physics Paper 1. So the first area we're going to look at is energy. So in this question, figure 5 shows a wood-fired hot tub. To describe the change to the stores of energy of wood, pipe and water as the water is heated. So pause the video now, then unpause the video when you want to go through your answer. Right, well, it's very important you can talk about the changes in energy store in a situation for a particular system. So what do we know? Well, firstly, the wood's chemical energy store is going to decrease. Why is that? Because the wood is being burnt, so the energy is being transferred from the wood to somewhere else. The second thing is that the internal or thermal energy store of the pipe increases because the pipe's being heated up by the burning wood. And then thirdly, the hot pipe is then going to go into the water, so therefore the thermal energy store of the water will also increase. And our next question, it says the temperature of the water reaches 42 degrees Celsius. The temperature then stays constant even though the fire continues to burn. So explain why the temperature of the water stays constant. So pause the video now, then unpause the video when you want to go through your answer. Right, so it's very important you can understand what happens to energies when the stores are being transferred. So it's important to note that energy is being dissipated to the surroundings. So what's happening is that the hot tub itself is losing energy to the surroundings, but it's losing energy, it's dissipating energy at the same rate as energy is going into the water. So as a result, the overall amount of energy in the water stays constant, so therefore the temperature of the water stays constant. In our next question, it says that figure 6 shows a bowl used for making ice cream. The walls of the bowl contain a liquid coolant. The bowl is cooled to minus 20 degrees Celsius before the mixture is put into the bowl. The bowl causes the mixture to cool down and freeze. So explain the different thermal conductivities of metal and plastic and why they're important in the design of the bowl. So pause the video now, then unpause the video when you want to go through your answer. So as mentioned previously, it's extremely important that you talk about both the metal and the plastic in your answer because the question is asking about both. So what would your answer be? Well, the first thing to note is that the metal has a high thermal conductivity. Now that's important because it will increase the rate of energy transfer from the mixture, from the ice cream, whilst plastic has a low thermal conductivity, which means it's a good insulator. Remember, the higher the conductivity, the worse the insulator, and vice versa. So what does insulation do? It reduces the rate of energy transfer from the surroundings or to the surroundings, but obviously in this case it will be coming in from the surroundings because it's ice cream in there, a colder object. So you've always got to remember that insulation reduces energy transfer. Let's have a look now at our next question. So figure 9 shows a sketch graph of how the maximum tendon length during a jump changes with the speed of the kangaroo. Explain why a kangaroo can jump higher as its speed increases. So pause the video now, then unpause the video when you want to go through your answer. Right, so how can you do this particular question? Well, it's important to note that when we're doing this particular question, it's talking about the tendons, and what happens is when the tendon increases in length, the extension that the tendon can undergo when it's carrying out a jump will also increase. So we've got a greater extension. Now you've always got to remember when we're talking about energies that the greater the extension, the greater the elastic potential energy. And you should also be aware that when you have your larger elastic potential energy, when that then gets when the tendon gets released from its tension, that energy store will change to another one, in this case gravitational potential energy store, which will lead to an increased speed when that transfers to the kinetic energy store. The next question says a kangaroo has a maximum gravitational potential energy during one jump of 770 joules. When the kangaroo lands on the ground, 14% of the maximum gravitational potential energy is transferred to elastic potential energy in one tendon. The tendon has an unstretched length of 35 centimeters. When the kangaroo lands on the ground, the tendon stretches to a length of 42 centimeters. Calculate the spring constant of the tendon. So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you answer this particular question? Well, the first thing to do is you've got to ensure that you're changing your 770 joules into 14% of that, because that's how much energy is being transferred. So to do that, you do 770 times by 0.14. So you get an energy that's going to be transferred of 107.8 joules. The next thing we note is we're talking about elastic potential energy because the object's being stretched. So you can check in your equation book, and your equation book says elastic potential energy equals a half times by spring constant times by extension squared. Now we are given the extension in the question, but because what you know is it starts at 35 centimeters, it goes to 42 centimeters. So the extension is the difference. So it's 7 centimeters. But we don't work in centimeters in physics, we work in meters. So we convert our 7 centimeters to 0.070 meters. We can then pop our numbers in, 107.8 for the energy, and we've got 0.070 for the extension. So we say 107.8 equals a half times by k times by 0.070 squared. We then rearrange it as shown on the screen to make k the subject. So we get our answer to be 44,000 newtons per meter. So that is there working out our spring constant of our tendon. In the next question, it says that the electrical generators can provide 1.5 times 10 to the 9 watts of power for a maximum of 5 hours. Calculate the maximum energy that can be transferred by the electrical generators. So pause the video now, then unpause the video when you want to go through your answer. Right, well for this question we've got to know what our equation is, and our equation is that energy is equal to power times by time. So what we can then say is energy therefore is equal to the power, which is given in the question, 1.5 times 10 to the 9 multiplied by the time. But the important thing to note is we don't work in hours in physics, we work in seconds. So we've got to convert 5 hours into seconds. So we do 5 times by 60 times by 60, because there's 60 seconds in a minute and 60 minutes in an hour, so it's 18,000. So it's 1.5 times 10 to the 9 times by 18,000, which as you can see from the question is 2.7 times 10 to the 13 joules. In our next question, it says that figure 11 shows a battery operated drill. When the drill is turned on, the drill bit spins around. So describe the energy transfers in the drill when it's first turned on. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important in these types of questions you talk about what the starting energy store is and how it's going down, what the end energy store is and how it's going up, and then if there's any other energy transfer present. So we'll say it's a battery, we know that because it's told that in the question, so the chemical energy store of the battery decreases. Now it's a drill bit which is spinning around, it's moving, so therefore the kinetic energy of the drill bit increases, and there's also thermal energy dissipated to the surroundings. Always remember to talk about that if it's an open system. Our next question shows us that figure 2 shows some students playing a game of basketball. During the game, players bounce the ball off the ground. So describe the energy changes that occur when the ball hits the ground. So pause the video now, then unpause the video when you want to go through your answer. Right, like we mentioned again, we talk about the starting energy store and how it's decreasing. Then we talk about the final energy store and how it's increasing. And if there's another energy transfer in place for the third mark. So what do we say? The ball is moving at the start. So we say the kinetic energy decreases. Then the elastic potential energy increases because the ball is changing shape when it hits the ground. But there's also thermal energy dissipated as the internal energy of the surroundings or of the air. Our next question shows us, figure 3 shows a drink made from crushed ice. The drink is at a temperature of 0 degrees Celsius. A student investigated how the temperature of the drink changed with time. So describe how the student could have taken accurate measurements of temperature in time for this investigation. So pause the video now, then unpause the video when you want to go through your answer. Right, so how would we answer this question? So for each one, you've got to talk about what measuring device you would use and then what experimental technique you could do to get an accurate measurement. So for temperature, we measure temperature with a thermometer, and we can either say we would read it at eye level to avoid parallax error, or you could say you would have to stir the mixture before you take a measurement to get the temperature of the entire liquid. The second thing is the time, and the time is measured using a stop clock. Now again, you would say you would use your stop clock at regular intervals because you want to see how it changed with time. So you want to do regular intervals of time to see this change. Next question, figure 14 shows a football player kicking a ball towards the goal. The goalkeeper is trying to stop the ball crossing the line. After being kicked, the ball has a speed of 20 meters per second. The mass of the ball is 450 grams. Calculate the kinetic energy of the ball. So pause the video now, then unpause the video when you want to go through your answer. Right, in this type of question, it will work out the kinetic energy store. So this equation for 2022 is given to us on our equation sheet, and that is kinetic energy is equal to a half times by mass times by velocity squared. Now you are given velocity squared in meters per second, so that's fine, and you've got to convert your mass from grams given in the question into kilograms, because we always work in kilograms in physics. So 450 grams, as shown in the question, becomes 0.45 kilograms. So you sub in all the values as shown before. That's very important to get your second mark. You then work through the answer and you get it to be 90 joules. Next question. When a force is first applied to a piece of wire, the wire behaves like a spring and stores 2.25 times 10 to the minus 3 joules of elastic potential energy. Calculate the extension of the wire and give your answer in millimeters, and the spring constant is 2000 newtons per meter. So pause the video now, then unpause the video when you want to go through your answer. Right, with this type of question, like written on the question on the exam, you've got to use your equation sheet, and you know that elastic potential energy is equal to a half times by spring constant times by extension squared. So what you can do is, we know what the energy is from the question, 2.25 times 10 to the minus 3. We know what the spring constant is, 2000, so we can pop those numbers into the equation and have E as our unknown. Now it's then important, we can then rearrange this to make E the subject. So as shown on the screen, you can see it has been rearranged to make E the subject. You can then pop in all your numbers and make sure you put brackets in where needed, because if you just put them in without the brackets, sometimes the calculator won't work it through correctly, and we get our answer out of 0.0015. But because we've used joules and because we've used newtons per meter, our extension is going to be given in meters. Now the question asked us to give our answer in millimeters, so what we're going to have to do is we're going to then have to convert 0.0015 meters into millimeters, which is 1.5 meters. The next topic we're going to look at is the topics of electricity, which could come up on the 2022 examination papers. So in this first question, it says that the electric motor in a car is powered by a battery. To charge the battery, the car is plugged into the main supply at 230 volts. The power used to charge the battery is 6.9 kilowatts. Calculate the current used to charge the battery. So pause the video now, then unpause the video when you want to go through your answer. So for these types of questions, it's all about doing two things. It's all about looking for the correct equations, and it's also for checking that you've not got any prefixes in your values. So the first thing to note is 6.9 kilowatts needs to become 6,900 watts. And our second thing to note is that power is equal to potential difference times by current. So we know our power is 6,900. We know that our our potential difference is 230. So again, sub the values into the equation. 6,900 equals 230 times by current. Make current the subject as shown on the screen. Then it equals out to be 30 amps. The next question says a gas-fired power station has a power output of 50 megawatts. Calculate the energy transfer during 24 hours. So pause the video now, then unpause the video when you want to go through your answer. Right, so again, what do you have to do? Well, you've got to find the right equation. So we know that energy is equal to power times by time. Now again, the next thing we need to note is there a prefix? Yes, there is, 50 megawatts. So we've got to convert mega into just watts. Now mega means times 10 to the 6. So 50 becomes 50 times 10 to the 6. And then we need to have our time in seconds, because we don't work in hours, we don't work in minutes, we work in seconds. So what you would do is you do 50 times 10 to the 6 times by 86,400, because that's what 24 hours is in seconds, because we do 24 hours times by seconds, so which is 60, times by minutes, which is 60, so you get 86,400, so you get 4.32 times 10 to the 12 joules. In our next question, it says a person watched TV for 2 hours. The power rating of the television was 0.40 kilowatts. Calculate the energy transferred by the television. Give your answer in kilowatt hours. Then the cost of electricity is $0.12 per kilowatt hour. Calculate the cost of electricity used by the television in 2 hours. So pause the video now, then unpause the video when you want to go through your answer. Right, well in this question, the first thing we remember is energy is equal to power times by time. Now you might go, well, it's given in kilowatts, so do we not need to convert the kilowatts into watts, and the time is given in hours, so we convert the hours into seconds? Now normally we would, but if you notice on the question, it wants the answer in kilowatt hours, so you don't need to do any conversions because it says it wants the answer in kilowatt hours. So it's 0.40 times by 2 is 0.80 kilowatt hours. Now it says calculate the cost of electricity used by the television in this 2 hours. Well, we know that in the 2 hours we've used 0.80 kilowatt hours. Each kilowatt hour is worth $0.12, so therefore we multiply the two together and we get $0.096. Now again, you don't have to learn that equation, but you've got to use mathematical common sense or when you're working out your answers in GCSE physics. The next question says the power rating of a drill is 21.6 watts. The potential difference of the battery is 18 volts and the drill is turned on and 30 coulombs of charge flows through the battery. Calculate the time for which the drill was turned on. So pause the video now, then unpause the video when you want to go through your answer. Right, so again, how do we work this one through? Well, we work it out from a couple of things. Well, it's the first idea that what is energy? Well, in an electrical circuit, we can say energy is charge times by potential difference. Now, we know that because we're given the charge and the potential difference in the question, so it wants us to use that. The next thing we know is that energy is equal to power times by time, so therefore time is going to equal to energy over power. Now again, we know it's going to be that equation we're going to pick from the equation sheet because we'll have just worked out energy and we're being given power and we need time. So if we work it all through, energy equals 18, which is the PD, times by 30, which is the charge, which is 540 joules. We can then pop that into the equation that energy is equal to power times by time, and then say time therefore is energy. It's going to be energy over the power, so you do 540 over 21.6 equals 25 seconds. Now again, please note, to get full marks on your GCSEs, you need to actually show your full working out and substituting the values into the equation before you rearrange it. The next question says the drill has a power rating of 1,500 watts. The drill is used for 0.5 hours. The cost of using the drill is $0.15. Calculate the cost per kilowatt hour of the mains electricity. So pause the video now, then unpause the video when you want to go through your answer. Right, so again, the first thing we need to do is work out how many kilowatt hours of energy that we use. We can then multiply it by the cost per kilowatt hour to work out our total cost of the mains value. So what we would do is we say energy is equal to 1.5, which is the power, but we need to be in kilowatts. So 1,500 watts is 1.5 kilowatts, times by 0.5 hours, because we're doing kilowatt hours. So we've used a total of 0.75 kilowatt hours. Now the cost of using the drill was 0.175. So what we say is we do 0.1 divided by 0.75. So therefore that value is going to be $0.2. So that's the cost per kilowatt hour. Our next topic is the particle model of matter. So in this particular topic, we're going to look at the topics that will come up on the 2022 paper. So the initial temperature of a mixture was plus 20 degrees Celsius. The mixture froze at minus 1.5 degrees Celsius. The total of 165 kilojoules of internal energy was transferred from the mixture to cool and freeze it. So calculate the mass of the mixture to two significant figures. So pause the video now, then unpause the video when you want to go through your answer. Right, this is a very challenging question, but what you've got to remember is that the change in internal energy is equal to the change in potential energy, which is given by E equals ml, plus the change in kinetic energy of the internal energy, which is E equals mc triangle T. So what you need to then do is say, well, firstly, what do we know? Well, the total change is 165 kilojoules. Now, we don't work in kilojoules in physics, we work in joules. So it becomes 165,000 because kilo means times 10 to the 3. So we can then say that equals ml plus mc triangle T. Now, you'll notice straight away that we don't actually have a value of m. It's what we want to work out. But when we've worked out m via E equals ml, it's 255,000 m, and when we worked out m by E equals mc triangle T, it's 75250 m. So what we can say is 165,000 is equal to 75,250 m plus 255,000 m. So you can then add the two values together to say 165,000 is equal to 330,250 m, as shown on the screen. We can then work out what m is because we can divide one number by the other and we get 0.499621. And now it's asked us to work to 2 sig fig in this question, so we go 0.50 because we've rounded 0.499621 to 0.50. Now it's important to note, why is that first zero not a significant figure? Because we start counting significant figures after the first non-zero number. Right, our next question says, the air contained water that froze at 0 degrees Celsius. The change in internal energy of the water as it froze was 0.70 kilojoules. Calculate the mass of ice produced. So pause the video now, then unpause the video when you want to go through your answer. Now, like we said before, we said that the change in internal energy is equal to the change in potential plus the change in kinetic energy. But there's no change in kinetic energy because we're changing state, not change in temperature. So it's only equal to the change in potential, and that is equal to ml. So when we're changing state, we can use our equation E is equal to ml. Now what we could then do is we can then say E equals ml, so we say 0.70 equals m times by 330. Now it says 0.70 kilojoules, so we've got to convert that into joules. So 0.70 kilojoules is 700 joules, and it says that the specific latent heat of fusion is 330 kilojoules per kilogram. So we've got to convert kilojoules into joules, so we say it's 330,000. So we actually say it's 700 is equal to m times by 330,000. We then rearrange it and make m the subject as shown on the screen, and we say m is equal to 0.0021 kilograms. The next question says, the air also contained a small amount of argon. As the temperature of the air decreased from 20 degrees Celsius to minus 190 degrees, the argon changed from a gas to a solid to a liquid. So from a gas to a liquid to a solid. Explain the changes in arrangement and the movements of particles of argon as the temperature of the air decreased. So pause the video now, then unpause the video when you want to go through your answer. Right, in this particular question, you've got to think about how on earth can you talk about the different states. Now, you've got to not just talk about solids, liquids and gases, but rather what's going on as the temperature goes down, as it goes from a gas to a liquid, then a liquid to a solid, and then finally explain why that was. The question, if you remember, says explain it. So it's not just describing it. So how can we get our full marks? Well, what do we know when it's cooling down? Well, the temperature links to how fast the particles are moving to each other. So we say that as it's cooling down, the particles move slower. So that means in a liquid, it's moving slower than the particles move slower than if it was a gas, and if it was solid, they'd be moving a lot slower than if they were a liquid or a gas. Now, as they cool down, that means they're going to be getting closer together because they're not moving as much. Now, when you go from a gas to a liquid, we know that the particles are gone from being very spread out to being closer together, and then from a liquid to a solid, they go from a random arrangement near each other to a solid arrangement. So they've gone from freely moving to vibrating about fixed positions. Now, you've got to explain why this is. Now, remember, when we talk about particles, it's extremely important to talk about internal energy. So we said as it cools down, the internal energy decreases. Now, there are two parts of your internal energy: the kinetic energy, which decreases with temperature, and the potential energy, which changes with the change of state. Now, you'll note that you would talk about the fact that as the particles get cooled down, they'll be moving slower, and as they get closer together, they're more attracted to each other. Now, remember to talk about each stage in a different paragraph to separate out your thought process. In our next question, it says the power of a kettle was 2.6 kilowatts. The kettle took 120 seconds to heat 0.80 kilograms of water from 18 degrees Celsius to 100 degrees Celsius. Calculate the specific heat capacity of water used in this information. So pause the video now, then unpause the video when you want to go through your answer. Right, well, it's very important that we know what equation to use. So it's E is equal to M times by C times by triangle or change in temperature. So the first thing you need to do is you need to work out what our energy is going to be. Now, we're not actually given energy in this question. We're actually given the power and the time. Now, you've got to remember that energy is equal to power times by time. Now, if we look at the values, we're given our power in kilowatts. So we've got to convert that into watts. So it's going to be 2,600 watts, because kilo means times 10 to the 3 or 1,000, times by 120 seconds. That gives us an energy of 312,000. So you say 312,000 is equal to 0.80, because that's the mass, times by the specific heat capacity, times by the change in temperature, which is 100 minus 18, which is 82. Now, you can see and how we've worked it out in this particular mark scheme that you would write out all the values in your equations, literally substitute in the values. Then you make C the subject by rearranging. So we do 312,000 over 0.8 times by 82. Remember to have those brackets in. So you get 4,756. Now, the question states they give the answer to two significant figures. So that becomes 4,800 joules per kilogram degrees Celsius. Now remember, 4,756 rounds to 4,800, two sig figs, because 4 and 8 are the sig figs there, that's 2. So we can say it rounds up because it's a 5 there, and a 5 will always round to the next value up from it. In our next question, it says the reservoir stores 6,500 meters cubed of water, and the density of water is 998 kilograms per meter cubed. Calculate the mass of the reservoir and give your answer in standard form. So pause the video now, then unpause the video when you want to go through your answer. Right, well, this is all about density. So what we can say is from the equation book, density is mass over volume. So you pop in your numbers as shown on the mark scheme here first before we rearrange everything. Then we rearrange it and make mass the subject. So mass is 998 times by 6,500,000. So we get our answer through, and it then wants it in standard form. Now, to get it in standard form correctly, it's got to be between 0 and 9.9 times by 10 to the something. So that value works only when it's 6.487 times 10 to the 9 kilograms. The next question says a different washing machine transfers 380,000 joules during a washing cycle. 65% of the energy transferred by the washing machine is used to heat the water from 11 degrees to 30 degrees. The specific heat capacity of water is 4,200 joules per kilogram degrees Celsius. Calculate the mean mass of water heated by the washing machine. Give your answer to two sig figs. So pause the video now. then unpause the video when you want to go through your answer. Right, so how would you answer this question? Well, there's lots of things to do here. Now, the first thing to do is we need to convert the 380,000 joules into 65%, because that's how much is actually used to heat up the water. So you do 380,000 times by 0.65, which is going to be 247,000 joules. We can then say E equals M times by C times by triangle T, the change in energy, and we know the temperature, and the change in temperature is from 11 degrees Celsius to 30 degrees. So it's going to be 19 degrees Celsius. We pop in all our numbers. Now, as shown on the mark scheme, substitute all the numbers in first, then rearrange to make mass the subject. Remember to put your brackets in on the times at the bottom. We then get the answer to be 3.095 kilograms. Now, again, it wants the two significant figures, so we round 3.095 to 3.1. 3 and 1 are two significant figures, and because it's a 9 after the 0, it rounds up from 0 to 1. In our next question, it says a student was provided with a sample of solid stearic acid. The student wanted to plot a graph of temperature against time for liquid stearic acid as it cooled. Describe how the student could use the equipment in figure 4 to collect the data. So pause the video now, then unpause the video when you want to go through your answer. Right, when we want to work the answer out like this, when we're trying to plan an experiment, any experiment that we do, we've got to talk about a few things. Firstly, how to do the practical, what are we measuring, how are we measuring it, and what values are we going to take. So the first thing you do is you take your stearic acid and you place it in the test tube. You then boil water in the kettle and pour the boiling water into a beaker. You then place the test tube of stearic acid into the beaker and leave until the stearic acid begins to melt. So you then take out the test tube of the hot water, place the thermometer in the stearic acid. So now we'll talk about what we're measuring, the temperature with a thermometer. We would then record the temperature every 30 seconds for about 20 minutes. Now again, what you've done is you've said, I'm going to record it. For what times and for how long. You would say you'd use a stop clock as well to help with this. And then finally, to get accurate results, always think about on the last part of your method writing, how are you going to get accurate results? Not just results, but accurate results. And to do that, you'd have to stir the stearic acid during the experiment. If we look at the next question, Figure 5 shows a graph of the student's results. So determine the time taken from when the liquid begins to change state until it's completely solid. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important when you've got a time temperature graph for these situations that when it's changing state is when the line is flat, because the temperature doesn't change when the state changes. So when is the line flat from? It's from 900 seconds to about 160 seconds, so therefore our answer would be 740 seconds. Now with the same graph, determine the energy transfer from the liquid stearic acid in the first 100 seconds. The mass of stearic acid is 15 grams and the specific capacity of liquid stearic acid is 560 joules per kilogram degree Celsius. So pause the video now, then unpause the video when you want to go through your answer. Right, so what's very important is you take the information given in the question. So we know E is equal to M times by C times by triangle T. Now you can work out triangle T, the change in temperature, by using figure 5. So what happens in the first 100 seconds? Well, in the first 100 seconds it goes from 76 degrees Celsius to 69 to about 69 degrees Celsius, maybe a little bit higher. So therefore we're going to have a change in temperature of about 6 degrees Celsius. We have got a mass, but we've got it in grams, not kilograms, so we've got to convert it into kilograms, and we've got a heat capacity given to us. So we'll then pop out our value, say E equals M times by C times by triangle T, pop the numbers together, and we get 50 joules. Next question. It took 132,000 joules of energy to melt all of the ice. The mass of the ice was melted was 0.40 kilograms. Calculate the specific latent heat of fusion of ice. So pause the video now, then unpause the video when you want to go through your answer. Right, so what's our equation? Well, we know from the equation sheet that E, the change in energy, is equal to M times by the specific latent heat. So we say E equals ML, so we pop our numbers in. 132,000 equals 0.40 times by the latent heat, L. We can then rearrange, now shown on the mark scheme, substitute the numbers in first, then work out what L is by rearranging as shown on the mark scheme, and we get 330,000 joules per kilogram. The next question says, describe the changes in arrangement and movement of the particles as the ice melts and turns to water. So pause the video now, then unpause the video when you want to go through your answer. Right, so you've got to talk about both the arrangement for 2 marks and the movement for 2 marks. Now again, it's very important we're describing it. So we're not explaining it, we're not talking about energies because we've not been asked to explain it, just to describe it. So the arrangement is that it's a solid, we know the particles in a regular pattern, whilst when the particles are in a liquid, they've got no fixed arrangement, they're freely moving. So we can say that the movement is that for a solid object, the particles will only vibrate about a fixed point, about a fixed position, but the particles in a liquid are free to move. So it's important when you ask a question like this, you talk about both sections of it and look at the key word. It's not about explaining it, it's just describing it. The next question says, the steam iron is set to its maximum power of 2,530 watts. Calculate the maximum mass of water that can be converted into steam in 1 minute by a steam iron, and you're given the latent heat of vaporization. Give your answer in grams. Then explain why the actual mass of steam produced will be less than the maximum value calculated previously. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you work this one through? Well, again, you know that when you're working out the change of internal energy when you're changing state, it's E is equal to ml. So we can say that therefore M is going to be equal to E over L. Now you are given L in the question, but you're not given E. But you are given the power and you are given the time. And you should always remember that energy is power times by time. Now what's our power? It's 2,530 watts. And we times it by not 1 minute, because we don't work in minutes. In physics we work in seconds, so we times it by 60 because there are 60 seconds in 1 minute. So we get our energy to be 151,800 joules. We then pop the values, substitute them directly into the equation because that gets us a mark on the mark scheme. So it's 151,800 equals mass times by 2,300,000. We then rearrange, make mass the subject, and we get mass is equal to 0.066 kilograms. But the question didn't want the answer in kilograms, it wanted in grams, so then convert it back into grams, so it's 66 grams. Now why will the mass be less than the maximum value calculated? Well, it's the point that we're assuming all of the energy is transferring from the iron to the water, but as we know, in every energy transfer there's always some energy dissipated to the internal energy of the surroundings. So it could heat up either the iron, it could heat up the temperature of the water, or it could heat up the surrounding air. The next question says a cooling station has a power of 350 megawatts. It cools water from 12 degrees to 7 degrees Celsius. Calculate the mass of the water that the cooling station can cool each second. So pause the video now, then unpause the video when you want to go through your answer. So like the previous questions, we know that E is equal to M times by C times by triangle T. But the trick is here, we're not given E, we're given power and we're given time. Now we can say that energy is power times by time, so it's 315 million, or 315 times 10 to the 6, because mega means times 10 to the 6, times by 1, so we get 315 million joules. We can then substitute it directly into the equation. So we say 315 million is equal to mass times by 4,200 times by 5, because it's the change in temperature. So it's 12 minus 7. We then rearrange it and make M the subject. So we say 315 million is divided by 4,200 times by 5, where there's a bracket around the bottom part of that equation, and that equals 15,000 kilograms. Right, so I hope you've enjoyed this particular revision session. If you feel you've been successful and learned in this revision session, you should be able to answer GCSE Physics examination style questions, assess your understanding on GCSE Physics, and understand what topics you need to improve upon for GCSE Physics Paper 1. So I hope you've enjoyed this particular revision session on GCSE Paper 1 for separate science physics for the 2022 topics. Thank you very much for watching and have a lovely day.